to video lesson 6.6, Graphing Linear Inequalities. Go ahead and put today's date in the top right-hand corner of your paper, and we'll start off with our I can statement. And it is that I can graph linear inequalities on a coordinate plane. Now, we've graphed linear inequalities before, except on a number line. We're going to look at graphing inequalities on a coordinate plane. So inequalities must be in our slope-intercept form, must be in y equals mx plus b to graph. And just a real quick reminder, remember when you multiply or divide by a negative, the inequality symbol flips. So those rules we had back in chapter 3, they're still relevant. We're still going to use them today with multiplying or dividing by a negative. The inequality symbol will flip. Now, inequalities graph a little bit differently than equations. There's a couple of symbols we need to go over. So, graphing our symbols. The very first thing it does is it changes our line type. We have our first line, which is y is less than or greater than. If you notice, these inequality symbols don't have lines under them, so that means it's a dashed line because that line's not going to be included. It's equivalent to an open circle when we did those on a number line. So if it's less than or greater than, it's a dashed line because it's not included. Our second line type is for when y is less than or equal to or greater than or equal to, because the line is then included in the solution because it is equal to it. Now our next thing is shading. So for shading, we're going to have, if y is less than or equal to, we're going to shade below the line. And if y is greater than or equal to, we're going to shade above the line. And over here are just some cases to look to. So for when it's positive, that means the line's going to go up and to the right. Above it is on this side, and below it is underneath it. For negative, so when your slope is negative, above is over here on the right side now, and below is on the bottom left. For a horizontal line, that's a little bit more straightforward, below and above. Our last one is vertical. And whenever you have a vertical line, remember that's for like when you have x equals a number, because we go through your x-axis at that number. It acts in like a number line, where below is everything less than's to the left, so less than is left, and then above is everything to the right, greater than to the right. But just sketch out these different types of slopes. That way, whenever you see them, you can always double check yourself and make sure you've shaded the correct region. Now, because they're just a little bit different than equations, we're just going to write down a couple of our steps. So step 1 is to write your inequality in slope-intercept form. You want it to look like y equals mx plus b. The only difference is this symbol will be different. It won't be an equal sign today. Now, our second step is to find our slope, and once again we're graphing, so it's m equals rise over run, to find our y-intercept, which is our variable b. And remember, it's for when we write it as an ordered pair, 0, because it's the y-intercept and then your number. Now step 3, we begin with b and use our slope for our points. Now, if you look, these first 3 steps haven't changed at all. They are still the same 3 steps we've been using throughout the entire graphing process. Step 4 is where it changes on us. So step 4 says determine the line type and graph. So our line type brings us back up to the top where we have to choose if it's less than or greater than, it's a dashed line, or less than or equal to, or greater or less than or equal to, it's going to be a solid line. So determine our line type. Then step 5, determine the area to shade, and that's our above or below. If it's Less than, it's pointing to the y, it's calling him little, so we shade below our line. If it's eating the y and calling the y greater than, then we're going to shade above. And lastly, we always want to make sure we shade the whole region. Alright, so let's look at some examples now. Example 1 says from the set 1, 6, 3, 0, 2, 2, and 4, 3. Which ordered pairs are part of the solution set for 3x plus 2y is less than 12? So there's two ways you can do this. You can go above your ordered pairs and write x and y and plug in the values into your equation and make sure it's less than 12. Or what we're going to do today is we're going to graph it and then check the ordered pairs. So once again, if this is my inequality, I need it in slope-intercept form. So I need it to look like y equals mx plus b. So that means I'm going to keep my 2y on the left because it's already there. I'm going to drop down my inequality symbol. It must stay an inequality symbol. Okay? Just drop it down as is. And then I have my mx and it needs to come over, so my 3x is positive. And I bring it over here, so it become a negative 3x. And I'm going to drop down my plus 12, which is just my number. So now my last step is to get y alone, is to divide everybody here by 2. So 2's cancel. Y, and then we always check we divided by a positive, so my inequality symbol stays the same, is less than, because it points to the y, calling him little, so y is less than. Negative 3 over 2 doesn't reduce, so negative 3 over 2x plus 12 divided by 2 is 6. So step 1, get it in slope-intercept form, we're good. Step 2 is to find your m and your b. So m is negative 3 over 2, and our b is 0, 6. And now we're going to graph this information we have right here. It's always the final product we always look to when we graph it. Okay? So my b, where I begin, and it tells me to begin at 0, 6. I'm going to go up 6 on my y-axis. So 0, 1, 2, 3, 4, 5, 6. Then my slope is negative, so it tells me to go down 3, so down 1, 2, 3, and right 2. 1, 2. Down 3, 1, 2, 3, right 2. So I've graphed my y-intercept and my slope. Now the next thing I need to determine is what type of line. So we always look to our last inequality symbol and say if y is less than, it's not equal to it, so therefore it's going to be a dashed line because it's not equal to. So come back over here. Oh, let's try our dashed line a little bit better. If you have a pencil, usually if I have a pencil, I make one solid line. I go back through with my eraser and put in the marks to make it a dashed line. Okay, and then my fifth step is to determine where to shade. So once again, we always go back over here to our inequality symbol, and it says if y is less than. So it's pointing to the y. So if y is less than, we shade below. So over here, we're going to shade below it. And below, for a negative slope, is everywhere to the left. And step 6 is to make sure you shade the whole region. So look, my line goes all the way across my graph paper. That means I have to shade this whole region, the whole side of my graph paper. There we go. Now the original question is if these ordered pairs are a solution. Well, this green area now is my solution region. So we just see if these ordered pairs are in my solution region. If they are, then that means that they are a solution. If they're not, that means they're not a solution. So I'm going to real quick go back and box in my information. This is all my information for my graph. Now, let's see about these ordered pairs. So 1, 6. So write 1 up 6. 1, 2, 3, 4, 5, 6. Is that in the green region? No, it's not. So that's not a solution. So then we try 3, 0. So start at 0 and then go right 3 and then 0 so we don't go up or down at all. And that is in the green region, so it is a solution. Then 2, 2, so right 2 up 2. That's also green, so it's a solution. Then 4, 3, so right 4 up 3, that one's not, so that one's not a solution. So our solution set for this would be 3, 0 and 2, 2. There we go, and we just found our solution region. So our second example just wants us to graph it, that's all. Just graph negative y minus 2x is less than or equal to negative 4. So first thing, we need to get it in slope-intercept form. Y equals mx plus b, except now it's an inequality symbol. And say my y is already on the left, so I drop him down, negative y. I drop down my inequality symbol, less than or equal to. And so if that's a negative 2x and it comes across, it's now going to be a positive 2x. Get rid of that stray point so it doesn't look like it's 0.2. It's whole number 2. And then I drop down my minus 4. Okay. So now we're going to say that's a negative 1 in front of our y. We're going to divide everybody up here by negative 1. So negative 1's cancel, and we get y. Now because I divided by negative 1, my symbol's going to flip and say y is greater than or equal to 2 divided by negative 1 is negative 2x. And then negative 4 divided by negative 1 makes a positive 4. Then we find our slope, which is negative 2. And because it's an integer, we write it over 1. And our b is 0, 4. And now we graph it. So 0, 4 is where I begin. So it's on my y-axis. So go to 0, then up 4. 1, 2, 3, 4. Then my slope tells me to go down 2, right 1, down 2, right 1. Then we come back here and we look at our inequality symbol. And we say, what type of line do I need? Solid or dashed? It's underlined, so I need a solid line. So we come back through here and make a solid line all the way across our graph. And then it says greater than. So greater than means we need a shade above it. So here's all of our information. Come over to our line, and for a negative slope, above it is to the right side. So we want everything above our line, everything up. There we go. And once we have all that whole region shaded, we're good. And this concludes our graphing inequalities. Thank you. Systems by graphing. There we go. So example 1. I always unstack them when I write them, just because where it's graphing, if I need to get it in slope-intercept form, I have space to do that. But here's the good thing. What do you know about these two inequalities? They're already in slope-intercept form. They already look like that y equals mx plus b. So the only thing we have to do then is find our m and our b and graph them. So for this first one here, I'll make it purple. What's his m going to be?
You want negative 1 over 1.
You got negative 1 over 1 because there's a negative 1 here for the x. And where are we going to begin? Where's their b? Where's it going to begin?
0,
0, 1. There we go. And now I'll go ahead and make my coordinate plane and get that started. So I'm just make a baby coordinate plane, 5 in every direction. Got x, y, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Alrighty, to graph them. We begin with B. So where does B send me in my coordinate plane? You got it, 0, then up 1. And now my slope is negative 1 over 1. So where does that send me? You got down 1, right 1, down 1, right 1, down 1, right 1. As many as you want to make. Now I know if this were an equation, we would make our line and we would move on. However, it's an inequality. So we have to go back here to our symbol and say if y is having the inequality symbol point to him, that means y is what? Less than. So if y is less than, what type of line do I need if it's less than? Dash, because it's not equal to it. And now I'm just going to make a dashed line over here. There's many ways to make a dashed line. You can do like I do and just kind of dot it out. You can also make a solid line and then go back through with your eraser and make like little marks in it to make it, oh, that wasn't a very good example, to make it look like it's been dashed. There we go. Oh. So a couple of different ways to do it. Now, I'm still not done. What's the last thing we got to do with it? Shade it. So if it's, once again, y is less than, where am I going to shade for less than? Below it. You got it. Now, I always like to think about our y-axis. So there's our y. Is below going to be up or down? Down. So I'm going to take it this way. Turn your pencil like this and really, really lightly shade it up and down below this line. So that line is our boundary line. We can't cross it. We got to do it everywhere below it. And if you notice, I go all the way across my coordinate plane. I shade in the whole coordinate plane all the way across there with that first inequality. And now we have it graphed. Second inequality, we'll make blue. So blue. So what's his m going to be?
2 over 1.
2 over 1. You got it. Where's he going to be, Ken?
3.
0, 3. You got it. So remember, we're going to begin with B. And this is why we want to shade really, really lightly. Because now I'm going to have to graph this on the same coordinate plane. So I'm going to go to 0, then up 3. 1, 2, 3. And where's my slope send me? 2 over 1 sends me. You got up 2, right 1. And then if I can't go up 2, right 1 anymore, I can go down 2, left 1. And now we have to decide what type of line do we need. If y is going to be greater than,
Solid.
there we go. So we got greater than. So greater than or equal to means what type of line? Solid. All right. Make a solid line.
Either way, it's going to be a solid line.
Yeah, either way it's going to be a solid line. You got it. And now, if we use the greater than symbol, where are we going to shade? I know. But for us, we're going to shade where for greater than? Above. We always want to go above or below. So where it's the y-axis, it means it's going to be up. So, up here, I'm now going to shade this one left and right really, really lightly, everywhere up to my blue line here. And once again, my blue line's my boundary, but I shade in the whole coordinate plane.
So it needs to be below, right?
Yeah, you got it. Alright, we have both of our inequalities graphed. So now, what's our one last step we got to do? You got shade your solution region. So it's where you have that overlapping, that crisscross pattern, where they're both shaded in. So you want to find that. Mine's here where I have the blue and the purple. And then you kind of want to outline it first, make it a little bit darker so you can see it, and then shade in that whole region that you've just outlined. I get the magic of the Mondo, so I can do this right here. Make the marker really big. So my shading happens a lot faster. So if you grab an order pair, let me do it this way, inside this area. So we got 3, and then -2 puts me on the axis. Let's do one a little bit farther. We'll go like -3, oh, -3, +2. That was my fault. I'm sorry, I was looking at the wrong spot. So, -3, +2. What values are in each order pair? Huh? Oh, come on, guys. You know this one's on our test. What values are in every order pair? X and Y. You got it. So if you take your inequality that you were given, your y is less than negative x plus 1, and plug in those values, you can see if it works. So our y value here is 2. So 2 is less than, it's going to be a negative 3 plus 1. So what do two negatives make? Positive, so positive 3. What's 3 plus 1? 4. So is that true? Is 2 less than 4? Yeah, so that works. And you do the same thing with your other inequality and say y is greater than or equal to 2x plus 3. And now check it. What's our y value again? 2 is greater than or equal to 2 times x is negative 3 plus 3. So now what's 2 times negative 3? Negative 6. What's negative 6 plus 3?
No, negative 3. Negative 6 plus
No,
3?
you're right. You're good. Negative 3. You're right. Negative 3. Now, as far as it goes, you got 2 is greater than or equal to negative 3. Is that true? Yeah. Now,
That look like it.
so example 2. I'll try to make sure to copy these down correctly this time. So we got x minus y is less than negative 1. And x minus y is greater than 3. So double check me. Did I write them down correctly this time? Yeah, they're good. For both of these inequalities, what do we got to do this time? We have one extra step we didn't have last time. You got it. We got to get them in y equals mx plus b form. Now, if I get them into y equals mx plus b form, who's going to stay on the left side? You got to be a negative y drops down is less than, and your positive x becomes a negative x. Very good. And we drop down our minus 1. All right.
I wish you would pick one instead of 0.
Now, what do we got to do to finish up for y? You got to divide right up here by negative 1. And now, we're going to end up with negative 1's canceling, and y is
1x.
all right, so 2 negatives make it a positive. 2 negatives make it a positive. Well, we still are missing something here. What are we missing?
You flip the sign and divide by negative.
Very good. Awesome. We're now going to say y is going to be greater than. Why do we have to now say y is going to be greater than? We flip the sign because we divided by a negative. So make yourself a little note right here.
So if you divide or multiply by negative?
You got, if you multiply or divide by a negative, we have to flip the sign. So only if you multiply or divide by a negative, you have to flip the sign. So our less than now became greater than. And guys, I usually tell people to box in this answer because this is the inequality symbol we're going to look to. We're now going to use this symbol right here instead of the other one. So we got it in slope-intercept form. What's our slope going to be? 1 over 1. Where are we going to begin? 0, 1. I'll real quickly kind of sketch out my coordinate plane over top of this one. Once again, it's a little blurry. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X, Y, we're set. Thank you so much, John. Is that good for you? If you want to use it, you can keep it and use it. I'll take it at the end. Alright. Now, where are we going to begin to graph this one? 1. You got, so begin with B, 0, 1. 0, then up 1. And now our slope tells us to go where if it's positive 1 over 1. You got up 1, right 1, up 1, right 1. Now, before we can just make our line, we have to decide solid or dash. Because it's just greater than, it's going to be a dashed or dotted line, however you like to say it. So once again, however you prefer to make it dashed, you can make a solid line, then erase it, or you can just make dash marks on it. Alright? And because it's an inequality, we now also have to determine what? Where to shade. So if it's now greater than, where are we going to shade it?
Above.
Above, you got it. So above means we're going to shade up. So I'm going to go to this line right here. I'm going to shade everywhere up and down real lightly, and use that line as my boundary. There we go.
I feel like this one.
So now, we have our first one graphed. Take a second, let it sink in. Second one here, we graph it in blue, and we'll have y equals mx plus b. So that means who do we keep on the left? Y, so negative y. Drop down our symbol, so it's going to be greater than. And then transpose our positive x and make him a what? Negative x, drop down our plus 3, and we're all good. Alright, last step is solve for y. You got divided by here by negative 1. And negative 1's cancel, and y is going to be less than. Very good. We flip that symbol again because we divided by another negative 1. So that symbol flips. We know negative 1 over negative 1 makes a positive 1x. 3 divided by negative 1 gives us negative 3. And we're all good. This is the new inequality we use to graph. Alrighty. So what's his slope going to be? 1 over 1. And where are we going to begin? 0, negative 3. And some of you all may realize, is there anything in common you see between the purple and blue lines?
Same slope.
Same slope. Do you all remember what same slope means? What type of lines have same slopes? Parallel. You got it. So this one should be parallel to it. So I got 0, negative 3. So 0, then down 3. 1, 2, 3. Oh, those tick marks are very ugly down that way. Then my slope's up 1, right 1. Up 1, right 1. Now, we also have to determine line type. So, if it's less than, it could be dashed again. And so, once again, make a dash line however you need to. And because we flipped our symbol, this now says y is less than. So, we're going to shade below this one. So, I'm going to go down here and shade everywhere below it real lightly left and right. Alright, we have one last step. What's that last step? Shade. So you got to figure out where your solution region is and shade it really dark. Where's the solution region? You got it. This one doesn't have one. It's where they overlap, where they have a shared region, and they don't have anything shared. So what should I put for this one? No solution. So you can write out no solution, or what else could we do? You got make a circle with a line through it?